Everyone, and thanks for watching Edupedia World videos. I am Manish Agrawal, and in our first chapter of states of matter we'll start with the introduction to the topic and to the different phases of matter. Alright, so our chapter is states of matter, and once again we'll only cover it as per the syllabus of class 11 CBSE board. Okay, so let's start with the first thing, which is three states of matter. Okay, so broadly we can categorize matter into three different states or three different phases. Okay, so if you go into great detail we can define more than these three states, but these are the only ones which we have to talk about today. Okay, so you all are already aware of these three states. These are basically solid, liquid and gas. So a same substance can exist as solid and can exist as liquid and as well as gas under different conditions of temperature, pressure or volume. Okay, mainly temperature and pressure come into effect while differentiating between these three states. So for example, if you talk about water, then water can exist as solid, that is ice, okay, and it can also exist as liquid, which is water, okay, what you drink, and it can also exist as gas, which is water vapor or even steam. Okay, so that is an example of gaseous form of water. Alright, so likewise a lot of substances we can very easily observe their three different states, solid, liquid and gas, okay, without going to extremes of temperature and pressure values. So what we want to understand over here is the basic difference between these three phases, okay, and what are the different properties, okay, of a given substance. Okay, what are the different properties of a same given substance in these three different states. Alright, so see the basic difference, if you try and visualize say water in solid form, in liquid form and in gaseous form, the basic difference is based on the intermolecular arrangement. Okay, how the molecules are arranged, okay, inside the bulk of this substance. Alright, and how their motion is present. Okay, so what kind of motion or movement or mobility do they have in there and how they are arranged. Okay, so based on that we can very easily differentiate between these three states. Alright, but for now let's go into further detail. Let's talk about solid state first. So in solid state, if we talk about the forces of attraction, okay, so forces of attraction in solid state are very large. Okay, what do I mean by forces of attraction? So if you have say one molecule of the same substance and another molecule of same substance, then those molecules can attract each other. Alright, so molecule or atom, depending on what substance you are talking about. So this force of attraction, okay, this is very strong in solid, and that is why the solids, okay, the solids all over tends to be more or less compact. Okay, their molecules are closely bound to each other, because closely bound means their attractive force is very high. That is why they more or less stick together, you can say. Okay, then we can talk about thermal motion. Alright, so after force of attraction we can talk about thermal motion of molecules, that is how fast or how randomly are these molecules moving. So even a solid object, even though it seems like a solid object, is very still. For example, the computer, right now your computer, it might seem like it is still, it is not moving, but the molecules inside your computer, okay, the molecules which make up your computer are actually moving, though you cannot see it with your naked eyes. This motion might be say vibrational in nature. Okay, so we are generalizing all kinds of motion as thermal motion, whether it is vibrational, rotational or linear. So this thermal motion in solids is very negligible. That is why once again it seems like solid is not moving or your computer is not moving right now. Alright, if it is kept at a place, so because the motion of the molecules is negligible, and this motion is called thermal motion. Why is it called thermal motion? Because this motion is a result of thermal energy or temperature of your molecules. Okay, so you will understand this concept in a bit better way later on. So for right now, let's just assume that thermal motion in solids is negligible. Okay, and you should be able to visualize that. Now if we talk about the volume, the next property Okay, so in solids the volume is fixed. For example, if you have a say cube of ice, so its volume is fixed as long as that cube of ice remains as ice. Alright, so or you might have a wooden block. Okay, so that wooden block will have a fixed volume, or a log. Okay, so this is say a log of wood, so this will have a fixed volume, and if it's cylindrical you can calculate it as pi r square h. Alright, and the last property is geometry. So solids also have fixed geometry. What do I mean by geometry? I mean the shape. Okay, so if this solid is in this cylindrical form, okay, this log of wood is in this cylindrical form, then it will always remain in that cylindrical form. Okay, unless I forcibly change it. Okay, unless I forcibly change it somehow. Alright, so that is what we mean by definite geometry, that solids have a definite geometry or a definite shape. Now whereas if we compare liquids with the solid under these same four properties, then we'll find that liquid state, okay, have lower attraction forces. Okay, so their attractive force is smaller than what is present between molecules of solid. Okay, so that is why liquid seems to be somewhat less compact than solid. Okay, for a given substance, for the same substance, liquid seems to be somewhat less compact because the attraction force between molecules is lower. So the molecules tend to be bit further apart than what they were in solid state. So next, if we talk about motion, so motion, thermal motion will obviously be greater. Why? Once again, since force is small, okay, the force keeping the molecules together or in the vicinity of each other, since this force is smaller, the thermal motion will be greater. Okay, that is, they are not as tightly bound to each other as they were in the solid state, and hence they have greater freedom of movement or greater mobility. And hence these molecules will be able to move around from here to there and everywhere. Alright, so more or less. Okay, later we'll see that in gaseous this thermal motion is even greater. Now if we talk about volume, what do you think, whether liquids have fixed volume or not? So liquids do have fixed volume. Okay, obviously, for example, if you have say 1 liter of water, then that 1 liter of water will remain to be 1 liter of water. It won't change simply because I have poured that water, 1 liter water, into a 2 liter bottle. Okay, it will only fill up half of the 2 liter bottle because its volume is fixed. So even liquids like solids have a fixed volume, but unlike solids, they do not have fixed geometry. Okay, sorry, like solids, they do not have fixed geometry. Solids had fixed geometry, but liquids do not have fixed geometry. That is, they do not have a fixed shape. Then how do we decide what is the shape of my liquid, whether it is cylindrical, spherical, cubical? Well, the shape of liquid is simply the shape of the container in which it is poured. Okay, so for example, here the glass contains the water, so the water or the liquid phase of water automatically takes the shape or geometry of the glass or inside of the glass itself. Okay, so liquid will try and occupy whatever empty space is given to it, alright, based on the shape of your container. Okay, lastly, now if we talk about the same four properties in gaseous state. So in gaseous state, forces of attraction are least. In fact, they are negligible. Okay, they are so low that we can say forces of attraction are negligible. What do I mean by negligible? They are very, very low. In fact, we will assume them to be tending to 0 or approximately 0. That between two molecules of gas, there is no force. Alright, so they are not attracting each other, though there is some force present, but it is so low that for our purposes, okay, for our purposes and for quite some lectures, we'll always assume this force to be 0. Next, motion, the thermal motion. Since force of attraction is very low, there is nothing keeping the molecules, two different molecules of a given gas, say nitrogen. Okay, so two molecules of nitrogen are not attracted to each other, and hence they have greater freedom of movement. Alright, so it is quite possible that their mobility is higher, as a result of which thermal motion might be higher. In fact, it is observed that thermal motion in gases is so high that we call it random motion. What do we mean by random motion? So this is an important term which you must remember. Random motion means that the thermal motion is so high that molecules are randomly moving throughout your container. There is no fixed pattern to their movement. Okay, and in fact they do not even have fixed velocities. Okay, for example, if you have a solid, say a solid pen, alright, so this solid pen will move, say, in x direction, then all of its molecules will move in x direction, right? All of its molecules are moving together in x direction. For liquid, molecules might move to some extent in different directions, but in gaseous, one molecule has no effect on another molecule, so they can move in completely opposite direction as far apart as they like, or as far apart as it is possible for them to do so. Okay, so that is the consequence of random motion, that they are randomly moving everywhere and there is nothing stopping one molecule from another molecule. Okay, so next, volume. So as a result of this, that force of attraction is tending to zero and they are in random motion, gases tend to have no fixed volume. Okay, they do not have a volume of their own, at least for now. What we'll study, that volume is not fixed. So how do we decide the volume of gas? We'll look at it in the next lecture. Okay, so lastly we have to talk about geometry. So when we talk about geometry, just like liquids, we'll find that gaseous state does not have a fixed geometry. Gaseous state doesn't have a fixed geometry. Okay, it takes the shape of the container in which it is present. Okay, that is the best thing or best answer you can give. Alright, otherwise just simply say that they do not have a fixed geometry. Okay, you cannot discern a shape of gas. Okay, you cannot discern the geometry of the bulk gas. Okay, so like I said, in this chapter, that is in states of matter, though we had to study the differences between the three states, we'll mainly focus only on the gaseous state. Okay, and towards the end a little bit about liquid state, but solid state you will cover in your class 12th physical chemistry. Okay, you have a complete chapter called solid state. In that you will study it in great detail. Okay, all the different kinds of geometry and attractive forces and all that. But for example, for now we'll just focus on gaseous state, and in this gaseous state we'll first start with something called ideal gas and then move on to real gas. Okay, so right now we are talking about ideal gas, in case you didn't know. Alright, so what is ideal gas is something we'll see later on, but for now you already know the four properties of ideal gas, that is based on attraction forces, motion, volume and geometry. So these four properties you are already aware of now. So some other properties of gaseous state based on these four: they have very low density in comparison to liquids and solids. Okay, so generally we can say that their density is very low. Alright, why? Because they are less compact. Okay, since attraction force between molecules is low, the molecules tend to stay further apart from each other in comparison to solid and liquid, and as a result of which, for a given mass, okay, for a given mass of substance in its gaseous state, the volume occupied by that substance usually is higher, and usually in liquid the volume is somewhat less, and in solid the volume is least. And you can say in general, not always, okay, this is not always true, but generally you can observe that density of solid is highest and that of gas is least. Okay, so that is once again because forces of attraction in gaseous state are very low, and the molecules are in random motion and they do not have a fixed volume, so they try and stay apart from each other as much as possible. okay, and you can also observe this point from an energy point of view. Alright, so that is something we might look at later on in the chapter of thermodynamics. Now gases are highly compressible. What do I mean by compressible? That is, can I change their shape or can I decrease their volume by increasing pressure? Right? For example, if this is a sponge, okay, a piece of sponge, so if you press it from both the sides, alright, so it might get compressed and change its shape, right, like this. So that is compressibility of your sponge. Okay, so that is what we mean, that gases are highly compressible. That is, even by application of small amount of pressure, small amount of force per unit area on both sides, I can compress the gas to occupy and force it to occupy very small volume. But this property is much more difficult in liquids and solids. In fact, at your level of class 11th and 12th, you will always assume that solids and liquids are incompressible. Okay, in fact, in a lot of questions, even in your physics, you will find an assumption given in the question that assume the liquid to be incompressible, okay, or the solid to be incompressible. So that is because at your level we are assuming that by application of pressure, the volume of your liquid or solid will not change. Though it does change, okay, it changes, but we do not know by how much. We just know for now that it changes by very small quantity, so small that we can ignore it. But for gases, we have to take that change in volume into account because gases are highly compressible. Next, can we mix gases, solids and liquids, okay, separately? That is, if you have two different substances which are in solid state, two different substances which are in liquid state, and two different substances which are in gaseous state. Okay, so see, for mixing solids, it's very difficult because two solids cannot be easily mixed. Okay, their mixing is basically means you're forming an alloy. Alright, so it is a complex process, whereas for liquid you need to stir it often, right? At many times liquid doesn't mix together very easily by themselves. If you have two different liquid phases, you might have to use a stirrer, okay, or shake the glass a bit in order to ensure that your liquid has completely mixed and formed a homogeneous mixture. But for gas, you don't have to do anything. Alright, so gases can mix without any mechanical aid. You don't need a stirrer, you do not need to shake the container. Okay, the molecules, since they are in random motion, they will simply, okay, randomly move everywhere and occupy whatever space they can inside the container, as a result of which you get a homogeneous mixture throughout the container. Okay, so what do I mean by homogeneous mixture? That is, the composition of your gas inside the container will be uniform, okay, at every nook and corner of the container. Okay, that is why when you spray a perfume at one corner of the room, you can still, okay, smell it at the other corner, right? That is why, because the gas or the perfume molecules which are present in gaseous form can homogeneously mix throughout the room, okay, as a result of which you can smell them at every nook and corner. Okay, so these are the main properties, the theoretical part of your syllabus which we needed to study. From the next session, we'll go into the details of gaseous state and the gaseous laws. Okay, once again it will involve theory, but apart from that it will also involve graphs and numerical questions. Alright, so do revise this session before reading or moving on to the next lecture. Okay, so until next time, and once again thanks for watching Edupedia World videos.